Hi, this is Carla Westphal again from Saddleback College. In this video, we're going to take a look at using L'Hopital's rule for an indeterminate product. As our example, let's take a look at the limit as x approaches 0 from the positive side of x times the natural log of x. Now, if I look at where each individual factor goes, obviously as x is going to 0, well, that would mean x is going to 0. For the natural log of x, if we're approaching 0 from the positive side, that's actually going to negative infinity. Remember, we can see that by looking at the graph of the natural log function. As we come into 0 from the right, that function is going down towards negative infinity. We've got a vertical asymptote there. Okay. And anytime we have something like this, where we have quote unquote 0 times infinity or 0 times negative infinity, that's an indeterminate form. And that's one that a lot of people find harder to spot because you've known for ages that if you multiply anything by 0, you're going to get 0. So people see 0 as one of the factors, and they sometimes want to say, oh, okay, this is 0, this is great, I don't need to use L'Hopital's rule. The problem is, this isn't actually 0. Because when we take the limit as x approaches 0 from the right, we're not actually getting there. With our second factor, natural log of x, we can't get all the way to where x equals 0 because that's not even in the domain of this function. So we're looking at x values where x is really close to but not equal to 0. And that's the key. This is not exactly 0. If it was, wouldn't matter what I multiplied it by, I would get 0. Okay. But close to but not at 0, this is just really, really small. So this means I've got a small thing times a big thing. And when I have a product and one factor is small, that makes me think I should get something small. But when one factor is big, that makes me think I should get something big. So I'm getting conflicting pieces of information, so that's an indeterminate form. So anytime I have an indeterminate form, I know I want to use L'Hopital's rule. But L'Hopital's rule applies to indeterminate quotients, quote unquote 0 over 0, and plus or minus infinity over plus or minus infinity. So if I have an indeterminate form and it's not a quotient, I have to do some algebra first in order to convert it to a quotient. And here's the key. If I look at x times the natural log of x, I'm multiplying two things together. Multiplying by something is the same as dividing by the reciprocal of that thing. So I have two options for how I could rewrite this. I could say this is the same as the limit as x approaches 0 from the positive side. And I could say instead of multiplying by x, let's just divide by the reciprocal of x. So I could write this as a fraction, the natural log of x divided by the reciprocal of x. And of course, if I did that division, I would just flip and multiply, and it's equivalent to multiplying by x. Now, there were two factors. I could do that with either one. So I could also have said this is the limit as x goes to 0 on the positive side. I could keep x as it is, and instead of multiplying by the natural log of x, I could divide by the reciprocal of the natural log of x. Okay. Either of these is correct. Here's where we want to be strategically lazy. We want to pick the one that's going to be easier. Okay. Now, I'm thinking this is an indeterminate, both of these are indeterminate quotients, so that we can use L'Hopital's rule. Let's just verify that really quickly and then take a look at which one will be simpler. If I look here, the natural log of x, we already said that was going off to negative infinity. If x is going to 0 but x is positive, its reciprocal is going to positive infinity. So this is giving me an indeterminate quotient of the type infinity over infinity. If we look here at this option, we've already stated x was going to 0. The natural log of x was going to negative infinity, so its reciprocal would be going to 0. So this version gives me an indeterminate form of the type 0 over 0. So either way of rewriting this, I can now apply L'Hopital's rule, but L'Hopital's rule involves taking derivatives. I would rather take the derivative of 1 over x than 1 over the natural log of x. Even though I'm a calculus teacher and I'm relatively good at taking derivatives, I'm going to pick the one that's simpler. Okay. So that's my better option. But anytime you're converting an indeterminate product to an indeterminate quotient, you want to keep in mind that you have two options. Try and figure out which one looks simpler and give that a try. If it's not working, go back and try the other option. Okay. So now I'm going to apply L'Hopital's rule. Okay. So I'll say this is the limit as x goes to 0 from the positive side of the derivative of the natural log function is the reciprocal function, so that's just 1 over x. 1 over x, this, if I wanted to, I could rewrite as x to the negative 1. So I can just use the power rule. That's going to give me negative x to the negative 2. So that's the limit as x goes to 0 from the positive side of 1 over x over negative 1 over x squared. That's what my negative exponent there means. But now I can do this algebra because I'm dividing by a fraction, so I'm just going to flip and multiply. So this is the limit as x goes to 0 from the positive side of 1 over x times negative x squared over 1. I can cancel an x. So we've got the limit as x goes to 0 from the positive side of negative x, which is just 0. And that's it for this video.